In this video, I will go over the ACAP DataQ, which is an MQTT client installed in Access cameras as a service to get data out of the camera and showing what type of data and how you can use that one. So what you see here now is the initial user interface here, or the user interface, and here is an overview of everything, the data types that is going to be able to publish. So the first one are events. So here's the topic that you would listen to for events. The hash there is type of event. The difference between this client and the MQTT client on the camera is that this one will automatically publish all events when it comes. I will show you in a second. The second that we're going to go over are detections. So detections is the motion-based analytics, the bounding boxes of objects and labels being detected. And this one is using the same analytics engine like what AOA is using and what Access metadata is based on. So it takes the same internal data and it processes differently and making it a little bit more consumer friendly. So detections is typically for visualizing data. I will get into that. Trackers is based on the detections, but only publishes when objects move and typically used for automation. Paths is an object type that only publish when an object disappears and you get the full path and all the information of that object. Paths are typically used for data forensic applications. So typically you would say this data type is just, you can throw that right into a database and then the use case is after the database. Occupancy is understanding how many objects are present in the scene. I'll go over that one. Geospace is making a XY coordinate transformation to longitude and latitude. I will go over that. And then status is being sent every 15 minutes and you get the CPU load, you get the uptime, you get the average bandwidth and all that. So as a way of monitoring the Access cameras and device. So if we start with the events, we can go here and so these are all the event groups that you can quickly enable and disable. So we can disable these ones, and this one will just provide any ACAP that generates an events will be there. So these are just basically events coming in, and if there are events coming in here, you can double click them and you can see the payload and structure. Coming into detections, so I will enable detections. So this is a live camera. It's outside Access parking, and what you can see here now are objects moving. And there's some configuration you can do here in order to filter this one. To me, detections is using detection and getting this kind of visualization is mainly only to understand how the analytics works and to see that you are being able to filter. So you can set an area of interest. See here, let's see. That you may only be interested in objects starting over here or passing here. The area of interest is once it passes this area, it will continue to track the object. So it's a little bit different. It will not. So if this car coming in here, it's passing this area, it will keep continuing tracking this car, this vehicle, even if it passes this area. Typically be using, like that. You can set a minimum size. Minimum size is a little dangerous to use because you see how the Object size may vary very much depending on where they are. But typically this filter will only say that once the object is past this size, then it just ignores the image, the size of the object. So this one is basically telling that it needs to be at least this size. So let's see if we enable this one and click save. And now we're not getting anyone. So we can minimum size. I typically leave this one usually if you're getting false detections, and then you can set a maximum size. So you can set the confidence level. You need to rotate the data if it's upside down or not. And here is how long an object is allowed to stay idle before it is not being detected anymore. I can do this forever depending on my use case. Let's see if we can remove that one. Let's just go 5. And it shows the stationary objects and all the moving objects. Depending on in this scene, I would typically set for 10 seconds. Save, and you can see the counters going up, and 5, 6, 7, 8. So we should see most of them just disappear. Of course, there are going to be like small variations that it may detect things like this. But so and then we can filter on labels. I'm only interested in humans, vehicles, bike, bus, vehicle. That's the other vehicle, bag, car, truck. Typically for automation, I would use trackers. So this one will only publish when an object has moved more than 5% of the scene. This reduces the bandwidth a lot if you are monitoring live objects. And the trackers also has, beyond the bounding box, the bounding box would have, the detections would have a bounding box, a confidence level, and a label, and a unique ID. Trackers also have additional properties like where it came from, the distance, the age, and a lot more properties that makes it very easy to, when a tracker comes in and you can look at the age and it says, okay, it's only 3 seconds, I'll ignore it, or doing things like that. So this is live data coming in, and the last one are paths from the motion objects. This one shows the last 10 paths past this scene. And in this one, you can also click on, let's say we say this distance 77 car, that one. Here you can actually see the data structure that is being posted on MQTT. You get the class, you get the confidence, you get the age, the distance, color, the delta X displacement, the delta Y displacement from birth to death, the birth point, the birth Y. The point here is always the bottom middle. It's the center of gravity, feet by the ground or wheels by the ground. The timestamp when it was detected, the longest dwell time it had, and an ID. And then you have the path of an XY. So this was the first position it was detected, the first sample of that position, which is the XY, and the duration. It stayed half a second in that area before it moved to this one. And I've enabled geospacing, so I also get the longitude and latitude. So you get all the sample positions. So these are basically the tracker positions that is being sampled. And then it just displays this in a HTML canvas. Occupancy. So let's see here. It's moving objects, stationary. So let's do this. You're seeing, come on, 2 cars. Let's go to detections and just enable this one for 15 seconds, save, going into occupancy. Now what you're seeing here is 28 cars and 1 bike. And this data only published when any of the counters changes. So what you saw there was the max idle time. This went away, and now we have show displaying the cars. And so you can decide if you want to be detecting moving objects or stationary objects or both, and how many seconds it needs to be in the scene, and the stationary threshold. So if let's do this, and let's just put forever on this one, save, and getting into occupancy. This one says that it needs to be stationary, that if I'm only counting stationary objects, they need to be at least in the scene 2 seconds, but they also need to be, this doesn't really make sense, but this one is very much on the stationary, that it needs to be fixed in a very specific area before it is being counted. I'm just going to go down here, and for let's just go back to 10 seconds, save. Then geospace. Sorry, I'm going to click there right there. So the geospace is where you can you add 4 markers into this one, and each marker on the video represent a marker on a map. So this is Open Street View map, and so let's see, this one is the corner of this building right there. Number 3 is this one, number 0 is up here, and then you just click save and calibrate. And you can validate this map by, when you go to validate, and you can click on the image and you can see the red dot that it displays where it makes that transformation on where on that map it is. So the better that you do, you may tweak a little bit here before you start seeing that a good validation. And then we should see on, now we're setting into monitor mode, and now we can see on the map that we have live data coming in. Let's see if we can see some vehicles moving. And this data is, so this is an JSON object saying the longitude and latitude, the age of the object, and some little bit more information. And you can start plotting this and showing this for other people, because it's totally there's no identification that you can do in this area. The last thing is the MQTT settings, where you just, so this is the MQTT connection for the ACAP itself. If you have many cameras, you may want to have, so the property name is going to always include there. If you leave this empty, you're not going to get that property. So you're getting a property name and location. Location can be anything. It can be a longitude and latitude. It can be an address. Can be a street or whatever. So I just put the access parking, and this is in Lund. It really helps when you have like 10 cameras and you're getting the serial number, but it's very hard when when you're working on the use case or troubleshooting and understanding that this serial number belongs to this camera with a name, or this may also be a system ID, a unique ID for whatever system this data is targeting. So there are 2 MQTT clients. There's one in the ACAP itself that connects to the broker. There is also an MQTT client in this web page. And when an MQTT client runs in a browser, it cannot connect over TCP or TLS. It needs to connect over WebSockets. So this is what the WebSocket. So you need to have an MQTT broker that not only listens to 183 for the TCP, it either needs to be listening to the WebSocket port 1884 that I set here, or an 8884 for secure WebSocket. So my own local MQTT broker is enabled to listen to all these ports, 183, 883, 184, and everything. If it doesn't do that, if you're not getting this connection, if you go up to detections here again, so what you're seeing here is the subscription that the client in the browser is doing to the MQTT. So everything that you see here has been published to the broker. And this is a way for you to validate. You see it's a green connected. The green connected means that the browser MQTT client is connected to the broker as well. If not, this would be red and you would not see any of these objects. You can still do configuration, but you won't be able to visualize the objects. For that, it needs to an MQTT broker. And then just a little bit about. So if you start, we can start looking into a little bit on that. If we, let's take, was there any event here? I'm going to go up to my, let's see, and seeing if, so I have this, so I didn't have any events coming in from this camera, but let's go detections, just to detection. So we can take any camera here. So this is the detection data. Okay, so we don't see any data there. Oh, there we go, detection for this one. So detection comes in with a list of detected objects in that exact frame. So you're getting the class, confidence, age, X, Y, width, and height, and all that stuff. If you look at trackers, we can take this one. And so this is one movement of a car, confidence, age 4. It has been 4 seconds in the scene. It's moved 80% of the view. The current XY width and height. So the coordinate system in this one is 1,000 to 1,000 normalized coordinate system, regardless of aspect ratio and rotation, landscape, portrait, like that. The center of gravity point, the total delta X movement. So if this is negative, it means that the object moved left. If it's positive, it moves right. So it's really easy to if you want to start counting objects coming in that you only want to count left, just check that delta X is less than 0. Otherwise, it's going to be right. The same thing with delta Y. Negative is going to be meaning up, and delta Y means down. So this is the birth position of the object. Timestamp, the birth time, the idle time. So this is a really powerful. You're getting both an age, and so this is from the when it was first detected. The idle time is the current idle time, so it moves, and then if it stops, it is still being tracked, and the idle time will start increase. So you can do a lot with idle time applications and automations based on the idle time. Active means it's still being tracked. If this was false, it was going to be the last object of that ID. So we lost that object. Color white, and here are the properties that I'm getting: front and location, and then also the serial number. So you can do a lot with this, with the data being published here. We can look at let's see if can we get a status. So let's take this one. So this one is being published every 15 minutes. So you're going to have the average network for the last 15 minutes. And that is going to be in kilobits. So it's going to be 1.6 megabits. The CPU load is around 30. So this is basically the load average, but instead of digits, it's going to be in a Linux. It would say the load average would be 30, but I'll display it as 30. Uptime hours is 18 hours, and then the location and serial number. So that is DataQ, a very short run over all this data. So thank you for listening.